Okay, take 4. 6.1, angles and their measure. Recall from geometry that an angle is formed by two rays with a common vertex. And that vertex is considered to be the vertex of the angle. And the two sides, we're going to be viewing oriented angles in this class. And so we're going to be talking about the direction, an initial side versus a terminal side. When angles are situated or in a way that is in a counterclockwise direction, we'll consider those to be positive angles, and when they are measured in a clockwise direction, we'll consider them to be negative angles. So in these first few examples here, you can see the initial side is labeled as this to the right line, and you can see that it is moving in a counterclockwise direction, so this is a positive angle. In this next example here, there's an initial side, and this time we're moving in a clockwise direction to see the angle, and so this is considered to be a negative angle because it's moving in a negative direction, or in a clockwise direction. And then finally, this last example, we have an initial side, and we're actually going through an entire rotation of the circle plus even more, but we're moving in a counterclockwise direction, and so this angle is also positive. Let's try drawing some angles together then. So draw each angle, label the initial and the terminal side. So a negative 90 degree angle, let's first draw an initial side. There's an initial. And then we will move in a negative direction, so we're going to move clockwise 90 degrees. So that's going to be going straight down, and then that means that this would be called the terminal side. Terminal side. In the next example, 420, notice that's 360 plus 60, so this is going to be larger than a circle. So let's choose an initial side. We'll call this one initial. And then we will move through an entire circle and then an additional 60 degrees. And that's going to be a 420 degree angle terminating here. This is the terminal side. Notice it ends at the same place as the 60 degree angle. Okay, if angles are angles are said to be in a standard position if we put the initial side along the positive x-axis and have a the vertex located at the origin. Angles are coterminal if their terminal sides end in the same spot. So, for example, on that previous page, the 60 degree angle and the 360 degree angle are coterminal. We call angles quadrantal if they land on the borders of the quadrants, so on the x-axis or on the y-axis. Okay, for this next set of examples, let's draw negative 270 degrees first. So negative 270 on the plane means we're going to start along the positive x-axis and we're going to move 270 degrees in a clockwise direction. So that's going to end up here. It's going to end straight upward. And notice the easiest way I would recommend to get a coterminal angle would just simply to be add on a rotation of the circle. So negative 270 plus 360 is 90, and you can actually see from the picture here how this is clearly also a 90 degree angle, right? A counterclockwise rotation of 90. Okay, negative 450, let's try to do that one. Negative 450 starts here. That's because we want it in standard position. We're going to move in a clockwise direction, and we're going to move 450 degrees. So there's 90, 180, 270, 360, and an extra 90. So that would be a 450 degree negative angle. Add 360, and you can notice that this is negative 90 degrees, and negative 90 degrees is also another way of looking at this angle, right? It's just negative 90 degrees down there. Degrees are wonderful, but they're only one way of measuring angles. We actually have another way that we prefer in the calculus, which is unitless, because it's in terms of radiuses. So recall that the circumference of a circle is 2 pi r, which means that you would have about 6.2 r radiuses that go around a circle. So if you look at this diagram over here, you'll notice that this is r, this is approximately r, there's 3 r's, 4 r's, 5 r's, 6 r's, and then there's a little bit left over, which is about a 0.28 of an r. So a radius is just a radian is just a measurement of the radius, and we call that the angle. We bring it down and make the central angle here, and that's the radius. So the conversion factor is pretty simple. It's pretty straightforward then, because half of a circumference is pi, and half of a circle is 180 degrees. So 180 degrees is the same as pi radians. So the conversion factors, to change degrees into radians, you're going to multiply by pi over 180. And that's pretty clear if you think about it, because what you're doing is you're taking the degree measure you were given and multiplying it by the number of radians and dividing by the degrees, if you think about the units that are floating around here. And if you have a radian measure, then you'd want to cancel out radians and you'd want to be left over with degrees. And so that's how you can remember which direction these characters are going in, these conversion factors. In our class, we won't use C or anything else to represent radians. In fact, if there is no symbol, if we don't put a degree, then the angle is understood to be in radians. So now let's convert. So let's convert these angles. They're given in degrees into radians. So I'll multiply this by pi over 180. Seeing the 180 and the 360 cancel to leave me with 2 pi. 210 will multiply by pi over 180, allowing me to cancel out the zeros, and then I can factor out a 3, so this becomes 7 over 6. It looks like we're getting a 7 pi over 6 angle. Next, we have a pi over a 180. And this time 45 goes into here 3 times, and 45 goes into here 4 times, so we'll get negative 3 pi over 4. And then finally, big angle, right, bigger than 360 even, but if we multiply by pi over 180, again, 45 is the number that goes in. 45 goes into this 9 times, 45 goes into this 8 times, and so we get negative 9 pi over 8. Now let's try changing some radians into degrees. So now the conversion factor is flipped. We're going to be doing into degrees. So degrees goes on top, radians goes on bottom. Pi over pi, 180 divided by 3 is of course 60. But don't forget your degree symbol. This time we need the degree symbol. Here, multiply by 180 over pi. We can cancel out the pi's. 180 and 3 reduce to 60. And 60 times 8 is 480. Here, we'll do 180 over pi, reduce the pi's again. Let's see, 180 divided by 5 is 36, and 36 times 3 is 108. So we're getting a negative 108 degree angle. And I think we just have 3 problems left. We're going to change these ones. Let's see. Multiply by 180 over pi, so the pi's reduce. 180 divided by 4 is to 90 is to 45, and then that's 280 and so that's 315 degrees negative. We know the conversion factor is 180 to pi, so we shouldn't be too shocked here when we change pi into degrees and get 180. And then the last one that's a little fancy is don't get into a bad habit of thinking radians always have a pi in them. Convert, this would be 180 over pi, times 2 would be 360 over pi degrees. But if you're curious about what that number is, it turns out 360 divided by 4 is about 114.6. So the actual degree measure is about 114.6 degrees on that one.